Section 3.1, Graphs. Graphs is like pictures of equations. And because we're dealing with equations in two variables, so we need x and y axis. Remember, the x and y axis divides the paper into 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, correct? So x is positive, y is positive in first quadrant. X is negative, y is positive in second quadrant. X is negative, y is negative in third quadrant. X is positive and y is what? Negative in the fourth quadrant. And this guy right here is called origin, which has the components of 0, 0. Remember, x, y represents a point, which is an order order pair, and it's denoted by a dot on x and y axis. So when we say 0, 0, what that means is x is 0, so is y, correct? Which happens to be called origin. So the question is plot or graph the following points on the x and y axis, correct? Remember, x and y axis is just like two number lines perpendicular to each other, correct? So 2, 0, that means you go 2 units over and you don't go up and down, and there goes the point on the x-axis. Negative 1, 5, that means you go 1 left, up 5, 1, 2, 3, 4, 5, and that's point Q. R, which is 0, -2, that means what? You don't go sideways, but you go down from the origin 2 units. So that would be like 0, -2. And finally, we have the point W, which is -2, -3. So you go 2 to the left and down 3, and you will be right here on the x and y axis. So remember, the representation of ordered pairs on x and y axis, they're just dots, which represent point. So with that said, what do you say we do some examples and see how this guy goes? The first example is what? Graph. So this is like graph, right? So graph or plot, y is equal to x plus 1. Remember, this equation is called a linear equation. Linear means the graph is always a line. How do I know this is a linear equation? Because the powers of x and y happens to be 1. If either of these variables have a different power than 1, then the graph will not be a line. It will be a curve, which I can do that on the next page. So what we do, we plot some points. So select some random points for x. Make sure you have a nice mixture of negative numbers, correct? And you have a good old 0 and some positive numbers. So remember, I chose these numbers from top of my head. However, when it comes to y, I have to substitute these values for x in the equation to find the corresponding values of y. For instance, the first one is what? -2 plus 1, which is -1. The second guy is what? -1 plus 1, which is 0. The third value of x gives you y value of 0 plus 1, which is what? 1. Notice I'm just replacing the x values with what? These numbers which I came up with. So y is equal to 1 plus 1, which is 2, and y is equal to 3 plus 1, which is 4. So the order pairs are -2, -1, -1, 0, 0, 1, 1, 2, and 3, 4. So I'm supposed to, what? A, B, C, D, E. I'm supposed to plot these points and connect the dots. So here's the x-axis. Here's the y-axis, correct? So -2, -1. So 2 units left, 1 down. -1, 0. 1 unit left, stay there. 0, 1. So you're on the y-axis. 1, 2, you are right about here. 3, 4, 2, 3, 1, 2, 3, 4, right there. So now you put your straight edge or your Costco ID card, and membership card and just draw a straight line, and this graph is called a line. So these arrows indicate that this line goes forever on either direction, so it doesn't stop. That's what the arrows are for. The next one is what? Graph 2x plus y equals 0. First thing I do is solve the equation for y. So I subtract 2x from each side. So I get y is equal to negative 2x. There's much better way to graph these lines, but it's coming up in the later sections of chapter 3. For now, we're just going to plot points. Once again, I use my usual values of x. So now I'm going to find the corresponding values of y up of the equation. So in this case, this would be like what? Y equals negative 2 times negative 2, which is 4. So that would be like negative 2 times negative 1, which is 2. Remember, I'm replacing the x values here in the box with these numbers, which I came up with to find the corresponding values of y for each of the x's, which I came up with. So this would be 0. This would be like negative 2. And this would be like negative 4. So my order pairs are negative 2, 4, negative 1, 2, 0, 0, 1, negative 2, and 2, negative 4. So these are my 5 points, A, B, C, D, E, which I'm supposed to plot those on a x and y axis. So let's do this. 2 to the left, up 4, 1, 2, 3, 4. 1 to the left, up 2, right there. 0, 0, you're at the origin. 1 over, down 2. And 2 over, down 4. So there it is. Once again, you take your straight edge and draw a line which goes through these points and make sure the line is as straight as it comes. So once again, the graph is called a line. Do you see it? Question is, do you always get a line when you graph a relation or equation? Answer is no, depends on what the format of the equation. It depends how equation comes up in the problem. But for instance, notice this guy, it says graph y is equal to x squared because the power of x exceeds 1. So this is called a nonlinear equation. And the graph is no longer a line, but it's a curve, correct? And we will see what that curve looks like and what is it called. I'm sure some of you know how to do this. So if you just go in the equation and replace these values of x to find the corresponding values of y. So notice every time you take any of these values, you get a positive number because you're squaring it, right? So here you get positive 1, here you get 0, here you get 1, and here you get 2 squared, which is 4. So the order pairs are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4, correct? So A, B, C, D, E. So here's the x and y axis. So plot the points. 2 to the left, up 4. 1 to the left, up 1. You're at 0, 0. 1, 1, so you are right about here. And 2, 4. 1, 2, 3, 4, right here. So notice, if you put your straight edge, it's not going to go through a straight line. So that kind of gives you a clue that the graph is not a line anymore, because no matter where you put your straight edge, it's not going to cover all the dots at the same time. So that kind of tells you the graph is not a line, it's a curve. So if you connect the dot in a very nice, smooth way, like so, so you can tell the graph is a U shape. And this graph is so famous, has a name, it's called parabola. So it's a U shape which opens upwards. And the name of this kind of U shapes is called what? Parabola. What if the degree of the what? X is equal to 3, you know? Well, in that case, y is equal to what? Negative 2 cubed, which is negative 8. So this guy is negative 1, that guy is 0, that guy is 1, that's 8. So the order pairs are negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. Once again, I got what? 5 points. If you if you plot the dots on X and Y axis, excuse me, you get negative 2, 2 to the left, down 8, 1, 2, 3, 4, 5, 6, 7, 8, 1 to the left, down 1, 0, 0, excuse me, 1 over, up 1, and 2 over, up 8. 1, 2, 3, 4, 5, 6, 7, 8. There you go. Once again, if you put your straight edge on these dots, it's not going to line up on a straight line. So the graph cannot be possibly what? Line, so it's a curve. So if you carefully connect the dots, you will see the graph is like a snake. Do you see it? So this is called cubic, graph of a cubic function, right? We will see in upcoming section what a function is. So this is like a third degree polynomial equation. This is how the graph looks like, snake. What about the equation has absolute value? Well, remember, absolute value of a number is always positive because it measures distance. So every time you stick these numbers inside the bars, guess what? A positive number pops. Excuse me. So this is 0, that's 1, that's 2. So the order pairs, regardless of what the values of x is, the y component will be always rain or shine, what? Positive numbers. So here are my usual what? 5 points. Okay, here's the y-axis, here's the x-axis. Let's plot these dots. Left 2, up 1. Left 1, up 1. That's up 2. 0, 0, 1, 1. And 2, 2, right about here. However, in this particular situation, if you put your straight edge on top of these dots, you can tell you can draw a straight line. So if I connect the dots on either side of the y-axis, I get something called a V shape. Do you see it? So not a U shape, but a V shape, right? So this is a V shape, whereas this guy was a U shape. So that's like when you have power of 2, it's a U shape. Power of 3 is a snake, and absolute value is always a V shape, correct? Incidentally, later on we'll learn this point right here. It's called the vertex. That's the turning point of a parabola. Like if you are, going down the hill, once you get this point, then you go up the hill. So that point, the turning point, is called vertex. Whereas if you go down the hill like so, because as you go from left to right, you got to go down the hill, and then you get this point, and then you go up the hill. This guy is not called vertex, it's called cusp. That's C-U-S-P, which means a sharp turn. Okay, what if you have the square root of x? How would the graph of this guy look like? Remember, when you take the square root of a number, that number has to be 0 or positive numbers. So intentionally, I chose what? Positive perfect squares. So this is the square root of x. Remember, y is equal to square root of 0, which is 0. Y is equal to square root of 1, which is 1. Y is equal to square root of 4, which is 2. And y is equal to square root of 9, which is 3. So if you would plot these points on a number line, you get 0, 0, 1 over up 1, 4 over 1, 2, 3, 4 up 2, and 9 over Is that right? That's 4, 5, 6, 7, 8, 9, what? Up 3. Once again, if you put your straight edge on these dots, it's not going to go through the dots. So you can imagine the graph is not a line, but it's a curve. So if you carefully connect the dots, you get this. So the graph is like a U shape, which opens upwards, and it's the upper half of a U shape. So imagine you have this kind of graph, a U shape, which opens to the right side, but you're only getting the upper half. And that's how the graph of that guy looks like. All right, thank you.